operating system. So today we are going to discuss operating system. And what are the topics of this subject? We are going to deal here introduction, CPU scheduling, synchronization IPC, which is very important in terms of problem solving, deadlock, memory management, again once again it is a huge one, and file system. Out of these 6 topics, which is the introduction and all up to file system, what are the topics which are very important in gate point of view? Okay? The topics are, if you are observing the weightage of these topics, let's see, 1 to 2 weightage of introduction, 2 to 4 weightage of CPU scheduling, which is a very big chapter, we will see in detail as much as possible, 2 to 4 synchronization and IPC. Once again it is a big topic and it is a very good topic. Lots of information you will get by the time I am discussing this topic. Okay. Now next one is 1 to 2 deadlock, and memory management is 2 to 4, and file system is 1 to 2. So total weightage of this subject is around 10 to 12 mark, and we know that an operating system is a subject, such kind of subject which has weightage very huge, and consistently he is asking in exam. Like sometime he will ask 8 marks, sometime he will ask 10 marks, and sometime he will ask 12 marks. Okay, it is such kind of subject which is showing his performance in terms of gate paper consistent way. Okay, it is not like a subject which has 1 year 4 marks, next year 12 mark, and once again it has 5 mark. Consistently it has mark in gate examination. Which book you need to follow for this one? As a beginner, if you want, you can go with the Galvin, and if you want some more books, Tannenbaum is the best one. Okay, but I will say that my notes are more than sufficient for this gate preparation. Okay, but still if you have doubts, then you can go with the Galvin and Tannenbaum. So let's see this subject as detailed as possible. Okay, now let's see what is operating system. What is operating system? Okay, now we have multiple definition for this operating system subject. The first one which I am going to collect, I will collect few definitions which are essential for our discussion. Okay, so let's see. First one, it is a interface between user and hardware. Okay, now next one I will collect, it is a resource manager. Third one, it is a resource allocator. Now fourth one, it is a set of control programs. Okay? These are the few definitions which I have collected, and it will suit to our discussion also. This is the main important thing. Okay, it is an interface between user and hardware. Let's see what is the meaning of this one. Okay, here user is there and here hardware. Okay, in between this hardware and user, operating system is there. Now next question is this one, are we directly interacting with the operating system? No. Then what is there? What is the one more layer between user and operating system? Command line interface. Okay, in terms of text based OS, in terms of text based OS, it is, what is the example? Shell, or you can say that you are in terms of Windows DOS command prompt. Okay, example, because I have taken shell, so I am writing here which operating system? Unix. In terms of GUI, because generally we are very much habituated of nowadays using GUI, that is graphical user interface. Our example is what? Desktop. Okay, example of such operating system I am taking as Windows. Now what will happen? Suppose that, because we are very much habituated of using a graphical kind of thing, so I am taking an example of desktop. As a user, suppose that on my desktop screen one file is there, that is file 1 something. Okay, and as a user I want to access that file. I am clicking this file. This request operating system will take, and what it will do, it will go to the main memory, and it will check that file. If this file is present inside the main memory, then it will schedule on CPU. If it is not present, then it will go to the hard disk and it will bring that. Okay, now assume that this file is present inside the main memory. Now since we want to access this file F1, so definitely OS need to schedule this F1 on CPU. Now file 1 is running on CPU. Okay, after that operating system will get back this result of this file as an output, and it will return back to the user. So in this way operating system is acting like interface between user and hardware. Boss, instead of telling interface, can we say that in real life operating system is acting like a broker? My own definition regarding the operating system, because yes, it is acting like a broker also, we can say that. See, what it is a technology, boss, you can say anything, but it should match with the content. If it is not matching with the content, it is a meaningless. Okay, how it is? Let's see. As a user, suppose that you want to buy some land. Okay, now you are writing your requirement on that slip. Okay, receipt on slip. This requirement you are submitting to the broker. As I said, that operating system broker, that is operating system, and what our broker will does? He will search land based on our requirement, and whenever it is finding that content, it will come back and it will return output. Sir, I have found this one. So here, because broker is a mediator, operating system is also like a mediator. Think this one. Okay, so now the next definition which we will deal is, it is a resource manager. What is the meaning of resource manager? Let's see. Like CPU is a one resource, memory is a one resource, hard disk is a one resource. Generally in operating system, in our content, we are dealing with the three things only: CPU, memory, hard disk. Okay, how we are managing this resource? Let's see. Means operating system. Now suppose that if I am typing anything on screen, first thing we are saving that. After the completion of typing, we are saving. Now was one thing we need to think, that whenever I am pressing save, so what operating system does is it will allocate space to process, but which blocks on hard disk freely available right now, he need to manage that information. Okay, how he will manage? By using some free list approach, like a free space management concept is there, later we will see in file system. By using any one technique like free list approach, like that. Okay, yeah, bitmap approach, any one approach he will use, and he will manage that information. Right now, what are the blocks which are freely available on a hard disk? Okay, so based on that information, it will allocate. So what it is doing, it is managing what information it is managing right now on a hard disk, what are the blocks freely available. Okay, now next one, same thing if you are thinking in terms of memory also. If you want to execute any process, what do you need to do? As I am clicking, first of all, we need to bring that process from hard disk to the main memory. V means operating system. Okay, but by the time you are keeping process from hard disk to the main memory, it is necessary for operating system to know that what are the partitions inside the main memory right now freely available. Okay, if it is not managing that information, maybe loss of data problem will come, because one process will overwrite to other process. So it is necessary for operating system to manage that information right now, what are the partitions which are freely available on memory. Okay, now next thing, same thing with the CPU also. What we are getting with the CPU? See, operating system need to manage that right now CPU freely available or not. So this information operating system need to manage. Whenever CPU is becoming freely available, one interrupt will get triggered and scheduler will schedule some other process. So in this way, operating system is managing the information right now CPU is freely available or not. So that's why operating system is called a resource manager. Now same thing, third definition is also very much similar to the second one. Instead of telling managing, we are telling here allocation, because as you are typing any file, so who is allocating the hard disk to a file? Operating system. And if you want to execute any process, you need to bring that process from hard disk to the main memory. Who is allocating memory to the process? Operating system. Now, if you want to schedule any process on CPU, okay, so then who will allocate CPU to the process? Operating system. So that's why CPU, since CPU is a one resource, memory is a one resource, hard disk is a one resource, that's why it is called resource allocator also. Okay, now let's see the fourth one. It is a set of control programs. Since operating system is a software and software is a collection of programs, so what kind of program it has? Controlling program, like long-term scheduler, who is controlling the degree of multiprogramming. Later we will see in this course what is the meaning of long-term scheduler. Okay, long-term scheduler is controlling the degree of multiprogramming. Short-term scheduler, it is controlling the processes, but in what way it is controlling? At a time only one process should go. In this way it is controlling. It is not sending all the process at the same time. Okay, so it is controlling that information. Whenever it is get triggered, it will activate to only one process. It will not activate to all the process. Okay, medium term scheduler is there. So all these programs are what? Controlling program. So it is a part of operating system. So that's why it is called, it is a set of control programs. Okay, so these are the few definitions which I have collected, which is very essential for us to know. So here itself we have seen that what are the resource, what is the meaning of resource manager, what is the meaning of resource allocator, and all these things. Okay, now let's see resources. Resource. How many types of resources are there? Generally we are feeling that CPU, memory, that means main memory, hard disk or IO devices, registers, etc. The term resource, it is giving this illusion that these are the resources generally we are seeing. But in context of operating system, resources are classified into two parts. One is a hardware resource, another one is a software resource. Okay, and whatever we have listed here, that is hardware resource. Okay, now what is a software resource? Here software resource means programs only. Okay, semaphore, device driver, okay, pipes. Let's write file, it is finished, because everything is a file only. Okay, etc. If you want to see anything. So these are the resources generally we need to see here. But next question is this one: why I am discussing these things with you? This is the main question actually. Okay, hardware resource means, sir, we know these are the things. Software resource, this one. If I am telling resources are only this one, only this area, then my subject name will be what, sir? computer organization and architecture is a better subject for this one. COA is a better subject. Since I am dealing with the operating system is what, sir? This resources, whatever I have listed here, plus this software resources. It is a combination of two things, hardware and software. That's why generally people are saying that if you want to go through with the subject operating system, you need to have some little bit knowledge of hardware kind of things. Okay, so these are the two types of resources we have seen here. Now let's see what are the goals of operating system. First one, I am counting here. Convenience. Second one, efficient. Third one, reliable. Fourth one, portable. So these are the few goals which I have collected here. So let's see what is the meaning of convenience. Convenience means what? The general term which we are using for the convenience is user friendly. Okay, means what? You need to design such kind of operating system which is a user friendly. If user is not free with your system, then what? Everything is over, boss. How it is? Suppose that you have given one mobile phone to a child, and we know that even if you are giving your mobile phone to even 1 year old child also, what he will do? What he will does? He will do one thing. What? He will open your mobile and he will go to the directly YouTube and he will see whatever he want to see. 1-2 year child. Okay. This is why it is happening, because whatever the operating system you have designed, that is a what? User friendly. Instead of this one, if I am keeping some condition like, if you want to operate my system, please practice this 100 command. Then how many people will operate your system? Hardly 99% is out of the market, because only professionals can operate your system or trained person can operate your system. General user, it will not. Means though you are designing one of the best system, but since it is a not user friendly, so meaning is becoming 0. Why it is 0? Because see, that mobile, though it is a very high configured mobile, but it is not user friendly. That who will buy boss that? Who will practice 50 commands and 100 command? No one. So that's why our goal is what? Primary goal, we can say that whenever you are designing an operating system in for general desktops or mobile, it should be convenience. If it is not convenience, the remaining things, whether it is efficient or not, reliable or not, that is meaningless for us. First thing, allow user to operate the system. If he is not operating, means what? Everything become meaningless. Performance is a later thing. First, allow user to operate that. If he is not operating, performance will not come into the picture. Okay. So convenience is the best one. So let's see efficient. Efficient means what? Whatever the operating system you are designing, it should effectively utilize the resources. What kind of resources? Whatever the resources inside the system you are using, like CPU. You need to make sure that CPU should not remain idle for the longer period of time. Am I correct or not? Yes. Because of these things only, because you want to keep CPU as busy as possible, that's why different CPU scheduling came into the picture. Like if you are using first come first serve, one process is going for the IO, the CPU remains idle. So what is the use of first come first serve here? So that's why you came across with some other algorithm, okay, to keep CPU busy as possible. The same sense we can think in terms of memory management also. We are managing memory. Why? Because we want to utilize what is the goal of memory manager? To effectively utilize the memory efficiently or effectively. The same thing, what is the goal of CPU scheduler? To maximize the CPU utilization. This comes under efficiency, all these things. Okay. Now, reliable. What is the meaning of reliable? If you are designing an operating system, it should be error free. What is the meaning of error free? Everything is error free, because whatever we are seeing here, you may say this, whatever we are seeing here, that is a exe file and it is running fine. Here reliable means not that one. The reliable meaning is something else. Like reliable means here, suppose that you are writing one program, tuck, 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 nearly around 5000 line program, but you forgot to save that program, okay? And suddenly what happened? Your operating system hanged, your system is hanged. Then what you will do? What is the meaning of this one? The meaning of this one, you know that because you didn't save and you need to rewrite this total 5000 line once again. Am I correct or not? Yes. Okay. So that's why your system should not get hanged. So you need to design such kind of operating system. The best example you are seeing generally is if I am using semaphore. Semaphore is what? Operating system resource, and we know that, and we will see later in the course also by the time I am discussing semaphore. If the operations of semaphore, if you are not keeping in order, it will lead to deadlock. Okay. So it is a responsibility of a operating system designer, by the time it is implementing the semaphore operation, please keep in proper order. One minor mistake, it will lead to deadlock at any time. Got? That is the meaning of reliable. Portable means what? We know that portable means, it is a very general term, means it should run on multiple architecture. Okay. So these are the few goals of operating system. General, whatever the system we are using here, like or desktop or mobiles, our first goal is what? Primary goal is convenience. But there are few operating system where the primary goal is not convenience, where the primary goal is what? Efficient. Like your real-time operating system. Like whatever the operating system you are using in missiles, okay, in that missiles, whatever the real time is what? It should get, the work you have to complete at on time, okay. Then how you will complete your work on time? Pakka boss, system should efficient. If system is not efficient, you can't complete your work, okay. So generally like missiles and scientific application, we are using this efficiency is a primary goal whenever you are designing application operating system. Because why not convenience? Because whoever is operating that system, he is a professional and he knows that how to use all those commands. Okay, got? Okay, so with this we have completed our goals of operating system. But in general, for our desktop system or mobile, our primary convenience is our primary goal. Okay. Now let's see types of operating system. The first one which I am going to discuss is batch OS. Okay. Let's see. We know that memory is divided into two parts. One is OS, one part is related with the operating system. It is also called as kernel area or kernel space, kernel area or kernel space. And other part is user area or user space, we can say that. Okay. User space, generally it is a big one and it is divided into multiple parts to keep multiple processes here. Now job 1 is here, job 2 is here, job 3 is here, job 4, job 5, job 6, job 7. So 7 jobs are present in user space. Let's see what is the meaning of this one. This is CPU. Okay. Now we are scheduling job 1 on CPU. After some point of time, job 1 is going for IO. Then what will happen? It will go for IO. Then what will happen? CPU remains idle. Okay. How long CPU remains idle? Unless job 1 is not finishing its execution completely, CPU operating system will not schedule another process. Okay. If CPU remains idle, means what? Throughput will increase or decrease? Definitely decrease. Okay. Throughput will get what? Decrease. This is the main thing. What is the meaning of throughput? Number of jobs completed per unit time. That is called throughput. Okay. But if you are taking an assumption for second, per second, how many jobs you are executing? Suppose that in some system, if you are executing 100 jobs per second, and some system, if you are executing only 15 jobs per second, so you will say that system A is better than system B. Why? Because within 1 second, I am executing 100 jobs and it is keeping me interactive. And second system is very slow because it is not keeping me interactive. Okay. So that's why throughput is a main concern thing here. Okay. If throughput is good, system will become definitely good. So let's see, as we are discussing the different operating system, generally we are concentrating based on this point only. Okay. What is happening here? If a job is going for the IO, CPU remains idle. Okay. How long operating system will not schedule another job until and unless this job is not finishing its execution. So final conclusion is, boss, throughput is decreasing. Example of such operating system is what? IBM OS 2. This is an example, and this is a system. This batch operating system is a concept which is related with the 70s actually. Okay, in old days, and it has some stories also. Like in old days, what was happening? Our computer is like big hall. Okay, like whatever our big hall is there, that much big computer is there, and people used to write programs on punch card. Okay, one program in one punch card they are writing, and they are submitting to the computer operator. That whatever the computer is, that big hall computer, one operator is there who is operating that computer. Suppose that Mr. A has written something in punch card and operator is B. It is submitting to Mr. B for the execution. Okay. So now what is happening? Actually, it is not required that much here, but to understand the logic behind this and upcoming type of operating system, that this is essential for you. Okay. What is happening? Operator is taking, here card reader is there. Through card reader, it is reading your punch cards. If you are submitting 2-3 punch cards, it will read data from punch card and it will keep this data into tape, and from tape it will copy this data to memory. What is the conclusion of this one? Boss, if you are observing one thing, in order to bring just process inside the main memory, so much manual work was there. This is the main point actually I want to highlight here. Okay, so much manual work was there. Write in punch card, submit to the operator, and it will keep those inside the card reader. Okay, and from card reader it is reading inside the tape, and from tape to the main memory. So much manual work, so much headache. Still you didn't execute single job also. In order to just bring the jobs inside the main memory, this much manual work is there. That's why it is a very bad also in other aspect, other than this performance, other aspect. This is at the time of execution. This is before the execution itself is a manual work. This is the main thing, boss. Okay. So that means what? As a human being, we'll say that it is taking only 5 minutes, but for the CPU, it is a very huge time. CPU for 1 second also, it is a very huge time for the CPU. Why? Because CPU is executing in terms of nanosecond. Okay, terms of nanosecond. 1 nanosecond equal to what? 10 power minus 9. So just so many instruction it will execute. Like if someone is saying our CPU is 2.1 gigahertz, means what? If you are calculating, it will execute nearly around 200 crore instructions per second. And as a human being, how many instruction we will execute in our mind or in terms of act, physical act per second? 1 to 2. If I am asking you in 1 second what you can do, so you will say that I will blink 2-3 times my eyes in 1 second, or you will say that I will do like this for 4-5 times, not more than that as a human being. Okay, this much only in 1 second. But CPU will execute 200 crore instruction per second, boss. What is the difference? If it is not executing 200 instruction per second, forget about your video execution, boss. Suppose that it is working like human being only, where it is 3-4 tasks it is performing in 1 second. So forget about the video, playing video, boss. Even it will not put 1-2 dot on screen also, boss. Are you getting me or not? So that's why CPU is very fast. Okay. So with this, the main thing is Before, manual work was lot before keeping the process inside the main memory, but after keeping that process inside the main memory also, we have seen that even CPUs remain idle in batch operating system. Okay, so this is main memory actually, as I said that. So let's see some other type of operating system. Now let's see second one, UniProgramming OS. In some books he has given monoprogramming, meaning is same. Let's see what is the meaning of this one. Here this is hard disk. Some programs are there, P1, P2, P3, P4, etc. Okay, and this one is memory. And as we know that memory is divided into two parts, one is a operating system area, other is a user area. Okay, and CPU, IO devices. If I want to execute process P1, first of all, the basic funda of operating system is what? If you want to execute anything, you need to bring that program from hard disk to the main memory. Why? Because CPU will execute program from from memory, not from hard disk. Okay, so first, whatever you want to execute, you need to bring that program and you need to keep inside the memory. I am scheduling this process on CPU, process P1. It is running on CPU. And after some point of time, if it is require IO, then it is going for the IO. Now tell me what will happen with the CPU. If this process P1 is going for the IO, CPU remains idle. So that means same thing is coming which we have already discussed with the batch operating system. So that means what? CPU remains idle. So that means throughput will get what? Decrease. Throughput decrease. And we need to work on throughput increase. Okay, the main thing is this one. Then example of this operating system is what? DOS, disk operating system. This is the first operating system which is supporting to the disk technology. In the previous lecture, previous batch operating system, that is batch operating system, we have seen two things. The first thing, we have seen that CPU performance, this area. Second thing, we have seen here left side, how we are bringing those programs from card reader to tape and tape to the main memory. That was very manual headache. Okay, what is the advantage of this UniProgramming operating system as compared to the batch operating system is we are reducing that manual task of reading the programs from card reader to tape to the main memory. Whenever you want to execute any program, just to bring that program from hard disk to the main memory, it is a negligible amount of time as compared with the manual efforts of human being. Okay, so this is the advantage, main advantage. The performance wise both are very much similar. Okay, now let's see third type, multiprogramming OS. Okay, once again, later onwards after DOS, everything till now we are observing the hard disk concept is there, so no need to discuss. This is main memory which is divided into two parts, that is one is operating system area, other one is programming area. Here some programs are there in the user area, that is program 1, program 2, program 3, program 4, program 5. This is main memory. Okay, now let's see what is happening. This is CPU and IO device. Operating system will schedule, suppose it is scheduling process P1. Okay, same thing we will discuss. After running some point of time, process P1 went for IO device. Then what will happen? Scheduler will schedule another process P2, whichever is ready for the execution. If P2 is also going for IO, then scheduler will take another process. So in this way, whenever a process is going for the IO, operating system is scheduling another process on CPU. So what is the advantage of this approach as compared with the previous one? Very simple, because in this multi-program operating system, we are keeping CPU as busy as possible. If you are keeping CPU busy, means what it will affect in turn? Definitely throughput will get increased. Okay, so that means throughput increase. If throughput will if increasing means what? System will become more interactive. Okay. Now, example of this operating system is your Unix, Windows. Okay. So, this is the advantage of as compared with the previous two approaches. Now, next one we will see time sharing or multitasking. OS. Okay. So, let's see the same concept. Same concept is there, but what is the change in this? The time sharing operating system, it is an extension of multi-programming operating system. Okay. The first thing, it is a multi-programming plus preemption. Okay. Multi-programming plus preemption. We will see what is the meaning of preemption. What is the meaning of preemption means? If you are forcefully removing a process from the CPU or any other resource also, but since we are initial days, so that's why I am telling CPU. It can be main memory also, it can be other things also. Okay. Preemption means forcefully taking out resource from a process, that is called preemption. Non-preemption means process or on its own releasing the resource, or voluntarily we can say that releasing the resource, that is called non-preemption. Okay. So here what is happening means, in time sharing system, it is a multi-programming plus preemption, and here CPU is sharing its time among the multiple processes. CPU is sharing its time among the multiple processes. Okay. So, let us see. Suppose one example I want to take. This is a railway server and multiple users are submitting their request. User 1, user 2, user 3, user 4. And as a server, I need to satisfy each and every user's request. But how server will satisfy, this is the main thing. Okay. Here on server I am using, suppose that round robin scheduling algorithm, and I have mentioned that time quantum equal to 5. What is the meaning of this one? Whichever process is running on that server, it will run for 5 units of time. Okay. So, let us see, suppose that user 1, it has execution 10 units of time, it will also take 10 units of time, it will also take 10 units of time, it will also take 10 units of time. So, server is satisfying the first user request, it will run for 5 units of time. Now, context switching will occur on CPU and it will schedule some other process request. So, it is also 5 units of time, and it is also 5 units of time, it is also 5 units of time. As the last user is completing, once again system will serve to the first user. It is becoming 0, 0, 0, 0. If you are observing here, server is sharing its time among the multiple users, but the user is getting a perception that he is a single one who is using that system, but in reality it is not possible. In reality, server is satisfying multiple user by sharing its time among the multiple processes. If I am not using this time quantum 5, instead of using round robin technique, suppose that if I am using first come first serve scheduling algorithm, then what will happen? Let us see here. Until and unless user 1 is not finishing its execution, user 2 will not get chance, and user 3 is also not getting chance, user 4 will not get chance. So, that means what system will become less interactive, first thing. As I said that this is a server, boss, I have taken here 4 user example, but what will happen in India on railway server, there are many people, many requests are there. If I am using first come first serve on that server, one fine morning you went to book ticket, railway ticket, and you have submitted the request for the ticket, and he asked to sorry, he asked to transfer money also, and after transferring money he has given token number, your number is 5, then you will feel very happy because you know that after 4% you will get served. But how many chances are there? Every time you will get the token number early? Very less. It is it is next to nil. Okay. Now, instead of giving 5, if he is giving your token number is 50,000, then what you will do? You will wait. How long you will wait? Until unless all those whatever the request just before the it is not getting completed, you will wait, and you will waste your lots of time. So that's why server is using here time sharing system, where it is sharing its time among the multiple user, and because of that every user is getting perception he is the only one who is using, but in reality it is not happening. And that too also users are getting some information that their requests are getting processed. The main thing is this one. Okay. So example, nowadays whatever we are using, it is a time sharing boss, Linux or Windows, whatever nowadays we are using. Okay. Now operating system is generally classified into two parts. One is UniProgramming, as we have seen, and other one is MultiProgramming. Example of UniProgramming is DOS, and also we can say that batch operating system, because performance of these two operating system, as I have discussed, are same, throughput are same in both of this operating system. At a time they are satisfying only one request. Multi-programming operating system is classified into two parts. One is what? Non-preemptive. Other one is preemptive. Okay. Non-preemptive means process on its own releasing the CPU in this context. Okay. So example of this one is Windows 3.1 example. Preemptive means nowadays whatever we are using, boss, that is Linux. Okay. So these are the four types of operating system we have discussed. What you have learned with these four types of operating system? What is the main concentrating point? Till now whatever we have discussed, you need to keep some points also. Okay. The main thing is that in 4 out of 4 operating system, we are comparing that whether CPU is busy or not. Initial tools we have seen that CPU remains idle. Later we have designed multi-programming approach, and this is the extension of multi-programming approach, time sharing operating system. So, okay. So all this 3 we can say that because it is extension of multi-programming, so it is also multi-programming one kind of. So all these 3 operating systems, that is UniProgramming, batch operating system and multi-programming operating system, the main focusing point was whether we can keep CPU busy or not. Okay. So we want to keep CPU as busy as possible to increase the performance. Now let's see the first thing, the difference between program and process. Okay. What are the difference? Generally students are getting confused, sir, program and process. Very simple. We'll see few things which is very good, very essential also. Program, if I'm asking any student, they will say that, sir, program is a set of instruction, and process, that is also set of instruction. No. How we can say that? The reason is very simple, boss. If you are compiling any program that is present on hard disk, okay, if you want to execute that program, you need to bring that program. Suppose that this is the program A, it has the instruction like increment, decrement. Let's take as an example, increment, decrement, compare. These 3 instructions are there in the program. So after compilation, I kept on hard disk. If I want to execute this program, I need to bring this program from hard disk. I need to keep inside the main memory. This is hard disk. I need to keep inside the main memory. If I am keeping program A inside the main memory, Can you say that these instructions are changing here? No. These instructions remain same only after keeping that program inside the, because increment will remain increment only, decrement will remain decrement only, because these are the operation which you want to perform in your program, so it will not change. So one thing is compulsory, program is also set of instruction, process is also set of instruction. It depends that where those instructions are present. Okay, generally program present on hard disk and process present on main memory. Inside the main memory, process present. This is the first difference. But the program is on hard disk and this process can be inside the main memory. If you are using virtual memory concept, yes, process can be present on hard disk also, but some information of that process definitely present inside the main memory. Okay. Now next thing, after this one, with one program, we can't create multiple program. Okay. Now with one process, we can create multiple processes. Okay, let's see this one. Suppose that this is the program A which has fork instruction in it. Okay, and since if you want to create another program, because we know that the functionality of fork is what, to create another child process. In order to create child process, first of all, you need to run this program on CPU or not? Yes. In order to run on CPU, first of all, you need to bring that program inside the main memory or not? Yes. But where program is present right now? On hard disk. So that's why with one program you cannot create multi-program. Why? Because you are not giving chance to run on CPU, because as it is coming inside the main memory, it is becoming process. If it is there on hard disk, it will not create anything. Reason is very simple, it is not getting chance to run. If it is running, means it is become process. The same program, if you are running on CPU, definitely this fork function will get executed and it will create another child process. Suppose this is the process B. So that means what? Conclusion of the story is this one. With program you cannot create multiple process, but with process you can create multiple process. Okay. Next one is, it is a passive entity. Okay. And process is what I am writing here, active entity. Because process in action, process is in action and program is not an action. Okay, so that's why it is an active and it is a passive, because it is not performing any action. But my own analysis regarding this topic is, generally I say that program is like dead body and process is like alive person. Okay, so that's why if I am keeping a body inside the room, can you say that since I kept that body inside the one room, can you say that tomorrow morning if I am coming, then I will find this body in some another room? No, because it don't have any life. But as an active person, you are at the different places. Okay, sometime you are present inside the home, sometime after that you are coming to the college 9 to 5, after that you are going to the home, and late night 9 o'clock you are reaching to the home. But what is the meaning of this one? At different point of time you are at the different location. So process is also same, it is performing different action. That's why it is called active. Sometime it is present inside the main memory, sometime it is on CPU, sometime it is going for the IO. At the different point of time it is performing different activity. That's why it is what? Active entity. Okay, so these are the few differences which I have collected, which is necessary to discuss before proceeding towards the process concept. Okay, now let's see what is the meaning of process. It is a program under execution. Okay, now next one, it is a schedulable or executable unit. It is an active entity. Okay, so these are the few essential definitions I have collected. But one of my favorite, I will say that the first one, very important in terms of problem solving, in terms of understanding, very important. Okay, so let's see each thing. First one, it is a program under execution. What is the meaning of this one? Under execution means your program or process can be inside the main memory also, can be on CPU also, can be on IO also. It can perform any action. It can be present anywhere. As I said that at different point of time, process can be present at the different location. So your process can be anywhere. Now next one, it is a schedulable or executable unit. Boss, what you are scheduling? A process. CPU scheduler is scheduling a process. Or what you are executing? A process. That's why it is a schedulable or executable unit. Okay, because at the time of execution, what you are executing? A program which already became a process. It is an active entity. As I have already discussed that at the different point of time, it is performing different actions. That's why it is called as active entity. Now, as I said that process is like a person, human being. It has some attributes also. Attributes of the process. Next topic. What are the attributes of the process? Process ID. Okay. State, in which state process is there, whether it is ready state, running state, that is state of a process. And ID means what? By the time a process is creating, operating system will assign ID to a process. Okay, why? Because in future if you want to catch that process, so ID will work. Priority, what is the priority of a process right now? It is higher or lower as compared with the other process. Okay, the next one, program counter. Okay, program counter means what? It will show that which next instruction process want to execute. GPR, general purpose register. By the time whenever a process is executing, what are the register a process is executing? Okay, let's little bit example. It is, we'll see in detail by the time I am discussing the synchronization. Like if instruction is there, load RMX. So that means this register is called general purpose register. Okay. Now, next one, list of open files. List of open files. Second one, list of open devices. Means what is the meaning of this one? But at the time of execution, what are the files a process is opening or executing, and what are the devices a process is using? That information. Okay. Memory information. Means how much memory it has consumed, like that. Okay, etc. Many things are there, but these things are necessary to know. Okay, because if you are seeing Galvin, generally you will find more than 100 attributes of the process, but all those are not required for our discussion. Whatever the main attributes are required, yes, I am discussing these things. Okay, so now these are the attributes which are related with the process. Now as a human being, as I said that I will say I will always like a process like a person. As a human being also we have some attributes, like myself. What is my name? My name is Khalil Ahmed. Okay. Now next one is, what is my ID? Means roll number. Whenever I am taking admission in college, so they will assign some ID as a human being. In which state you are right now? Like process in generally ready state, running state, or block state, and we are also in some right now in some state only. Right now we are in active state, and by the time we are sleeping, we are in block state or we are in sleeping state, we can say that. Okay, so like that states are there. Priority. As a human being, we have also some priority was at home. My priority is more than my younger, and my priority is lesser than my elders. So each one has their priority. Okay, and generally in our homes also, our father and mother, both of them have higher priority as compared with the children's. Okay, so like this it is. So now means as a human being, we are also having attributes. Okay, if I am asking anyone, please give your attributes, then what you will do? You will collect that attributes inside the biodata form and you will submit to me. Means you are taking some help of some resource. Okay. Now here also process, what a process is doing means, by the time a operating system creating a process, it will create one more data structure that is called PCB, means process control block. In this process control block, it will store process ID, pointer, and whatever the attributes are there, attributes, state, priority, okay, list of open files, list of open device, like this. Attributes of the process collectively called as context of the process. Context of the process. Okay. So this is the data structure of this PCB, which is collecting all the attributes, that means information related with the process. Okay. Now let's see some other concept before proceeding this one, because I am discussing the context of the process means what. So now one concept is coming into the picture, that is context switching. So let's see what is the meaning of context switching here. Context switching. Here, this is the ready queue. In this ready queue, we have PCBs, which is related with the process, as I have just told this one. PCB1 means this information which is related with the process 1. PCB2, information related with the process 2. Okay. Suppose that right now on CPU, process P1 is executing. Okay. So now suddenly some higher priority process P2 came inside the main memory. Okay. So what we need to do? Presently process P1, it has some instruction right now, 1, 2, 3, 4, 5. Presently it was executing third instruction by the time I have preempted. Okay. So it has, by the time I have preempted, it has completed the 3 instruction. And it need to execute the remaining 2 instruction also, but this information we need to save inside the PCB of a process. Okay, and we have some attribute that is called like PC, as I have given here, PC, program counter. In this program counter, I am saving this information I4. So first action what I need to do means, I need to save the context of the running process, okay, and load the saved context of the other process. This is called context switching. First action is what? First action is save, and second action is load. Saving the context of running process, loading the saved context of the other process is called context switching. Are you getting? Yes. So in this way we are performing context switching. Who is responsible for performing context switching? Dispatcher is responsible for context switching. Who is responsible? Dispatcher. Dispatcher is responsible for context switching. What is the meaning of dispatcher? It is a small program which is performing all this task. Okay. So now let's see process state transition diagram. Process state transition diagram. Okay. Now this is the hard disk where some programs are present, P1, P2, P3, P4, P5, P6, like this. And whenever you are bringing program from hard disk, that is called new state, okay, or also called as create state. In some books he has given create also, the meaning is same. And you are bringing those programs from hard disk and keeping inside the main memory, and this is ready state which is present inside the main memory. From ready state we are scheduling that process on running state. This is CPU running state. After that, after the completion of its execution, process will get terminate. Now let's see block or IO. Block state. Okay. Whenever a process require IO, it will get block. IO require. We'll see after designing all these things once again. First, let me design this IO completion. So let's see. Whenever you are bringing a program from hard disk to the main memory, this is called creating state. Whenever your program is you are bringing from hard disk to the main memory, that journey is called creating state. It is not yet created. This is under the creation. Okay. After creation of the process, you are keeping inside the main memory. Here process P1, P2, P3, P4 is there. 4 processes are there. Okay. Now, who will bring this program from hard disk to the main memory? The first question is, it is a one type of scheduler that is called long-term scheduler. Long-term scheduler is responsible for bringing the process from hard disk to the main memory. Okay. Now, if you are observing here, inside the ready state, 4 processes are waiting, P1, P2, P3 and P4, and all are waiting for the CPU. But CPU is a 1. CPU is here what? Running state is CPU, but CPU is a 1. Who will go? This decision will make by the short-term scheduler by using some different CPU scheduling techniques. Who will make decision? Short-term scheduler, STS. After making a decision that who will go, suppose that he has decided that process P1 is an eligible candidate for running on CPU. This information he will pass to the dispatcher, as we have discussed previously. Dispatcher, I said that is small program, okay, not hardware, it is a program. It will pass, STS will pass this information to the dispatcher. Okay, now dispatcher is keeping this program or process on CPU. Okay, generally it is process, but in meanwhile discussion I will use interchangeably the program and process, because at the time of execution everything is a process only by default. Now this process P1 is executing on CPU. After some point of time, if a process require IO, then it will go for block state. After the completion of IO, once again it will come back inside the ready state. Okay. Now if process P1 has finished its execution, then it will go to the terminate state. These are the few basics of process state transition diagram. Okay, fine. But as for our knowledge, it is asked in one of the GATE exam also, this given process state transition diagram is preemptive or non-preemptive. It is a non-preemptive. Why? Because what is the meaning of non-preemptive? As I said that process voluntarily releasing the resource, means nobody is forcing a process to release the CPU. Under what condition process is releasing the resource on its own voluntarily? Whenever process require IO, it is releasing the CPU. Whenever process finishing its execution, it is releasing the CPU. So that means what? It is a non-preemptive approach. So process on its own releasing, nobody is forcing. Okay. To make this one as preemptive, I need to add one edge. In which direction I need to add? I need to add from running to ready state. So based on the what you will preempt a process, based on the timer. If you are using round robin scheduling, so we are defining the time quantum concept. Just I have discussed in time sharing operating system. Later I will discuss in detail that what is round robin scheduling algorithm. Okay, based on the timer or based on the priority. Some higher priority, like process P1 is running, suddenly some higher priority process came inside the main memory. So we need to remove this process P1 from running state and we need to keep inside the ready state and we need to schedule that higher priority process. So that means what? Forcefully we are removing a process from the CPU or not? Yes. So that's why it is called preemptive. Okay. So now let's see some other thing. Suppose that total memory is full and suddenly some higher priority process want to come, and execution of that process is very important. But as we know that if you want to execute any process, first of all you need to keep that process inside the main memory. But main memory is already full. Then what you will do? So we are creating one more state here. This is called ready suspended. So we will suspend any one of the process which has the lower priority. Assume that here process P1 has lower priority. I am suspending this process P1. So this is suspend. Okay. And whatever the process P5 which has the higher priority process, I am keeping here P5. I am scheduling that process on CPU. After the completion of that process execution, once again memory is becoming freely available. So I will resume this process back to the main memory. So this is resume. This suspension and resumption task, who will perform? This will perform by one more scheduler. This is called medium term scheduler. Medium term scheduler. Now next question is this one. Whenever your process is present inside the ready state, running state, block state, where your process is present? My process is present inside the main memory. Whenever my process is present inside the new state or ready suspended state, my process, where it is present? It is present on hard disk. Okay. So now let's see some more thing, because we are going to discuss subject means let's see whether it is related with the subject or not, or just as only like this only I have designed. Whenever my process is, if you are observing here, this is ready state, multiple processes are waiting for the CPU. Now based on the topics of operating system, which topic is, which chapter is applicable here? Here we can apply here CPU scheduling algorithm on these processes. Okay, by using the CPU scheduling algorithm, we are making a decision that who will go next. Like if I am first come first serve based on the arrival time. If I am using round robin, some other selection criteria is there. Now next one means what is our main goal to highlight this point? CPU scheduling algorithm, where we are applying is on this queue, ready queue. Okay, on this ready queue we are applying this CPU scheduling algorithm. Now next one, if you are observing, suspended and resumption task is there. So that means you are interacting with the hard disk. So that means what? This concept is somewhere around related with the virtual memory or not? Yes, it is related with the virtual memory. If there is no ready suspended state or suspended state, if it is not there, can you say that this system is supporting virtual memory? No. Why? Because the virtual memory meaning is what? It is an approach that make use of secondary storage as an extension of primary storage. Okay. Okay, fine. So in this way, but you are telling sir, what is the meaning of synchronization and deadlock, where it comes? See, those synchronization deadlocks are running runtime situation. Deadlock when it will come? Runtime. Synchronization means what? Runtime, when more than one processor communicating with each other, that situation. Okay. Now one more thing, sir, one more topic is there, that is file system. Yeah, here one more queue is there here. This is called device queue. This is ready queue. Okay. Suppose one process P1 is coming for the hard disk, some page fault is occur. P2 is also coming for the hard disk, P3 is P4. So all are asking for the hard disk only. Now more than one process are waiting for the hard disk, and hard disk is a single one. So what to make a decision, in order to make a decision that who will to whom we need to serve, we need to use what here? Disk scheduling algorithm. Disk scheduling algorithm. Got? Yes. So in this way, this process transition diagram is working. Okay. So you hope you have enjoyed this. So let's see some other topic.